Hello, I'm Eugene, and it's been a while. Today I'll go take a look at 1 to 105 Target 5. I'll read the directions first. One six-sided fair die has the following labels for sides: sine, cosine, tangent, cotangent, secant, and cosecant. Kara rolls a die, uses a random generator to pick one input from the set, I'll spare you the time, and applies a trig function from the side showing face up on the die to the input Kara picked to get an output if it is defined. What is the probability that Kara's output is defined and that the output is greater than or equal to 0.6? Express your answer as a common fraction, and there is a lot to take in. But taking a look back in the set, there's 16 elements in that set and six ways for the die to land. And both of these events are done at random and are independent. So that means total number of possibilities that are equally likely. 16 times 6 equals 96. But taking a second look at those values, those look very familiar. And with those trig functions, turns out those are the exact values that I was quizzed on back in the day. And those pre-calculus students learn all these exact values for trigonometry because they come in handy in pre-calculus and the math world beyond. But how on earth are they able to manage them all? Maybe it's time to take a look on where these come from. Well, those numbers, they don't really have this little circle in the upper right. That's because those numbers are actually in radians. Each degree has a radian counterpart. And with that, from those 30, 60, 90, and 45, 45, 90 triangles and the SOHCAHTOA rules, you can make a little table chart that tells you the exact values for sine, cosine, and tangent of pi over 6, pi over 4, and pi over 3. But that's only 3 values. There's a lot more that I'm quizzed on and that the problem was covered. Well, it turns out that the unit circle will come in handy. That unit circle gives us a new way to take a look at trigonometric values, because now the angles are now based on the angle formed from the positive x-axis and stuff, with the hypotenuse always being 1. Sine now represents the y-coordinate, cosine now represents the x-coordinate, and tangent now represents the slope, especially since tangent has always been sine over cosine. And we can also observe some interesting relations, like how sine pi over 6 and sine 5 pi over 6 are basically the exact same because the y-coordinate is the same. But cosine pi over 6 and cosine 5 pi over 6 have a sign flip. Cosine pi over 6 is positive, while cosine 5 pi over 6 is negative. We can observe those relations in these yellow rectangles, and with observations on sine and stuff, we can basically narrow down the amount of work we have to learn in order to master the unit circle. In fact, this unit circle comes in so handy that I'm just going to go draw a mini sketch version just to make solving this problem look a lot easier. All right, and with that, let's now get to the actual counting. First up is sine. So for sine, sine 0 is 0. That doesn't work. Sine pi over 6 is 1/2. That's less than 0.6. But sine of pi over 4, that's root 2 over 2. Root 2 is about 1.4. 1.4 divided by 2 is 0.7. And that definitely clears it. And same thing goes for sine pi over 3 and sine pi over 2. And with the unit circle, we can observe that that 5 of these values work for sine. So we can write that sine works for 5 of the values. As for cosine, cosine pi over 6 is going to be square root 3 over 2, which we said it works. Cosine pi over 4 is root 2 over 2. But cosine pi over 3 is 1/2. That does not work. But cosine pi over 6 and cosine pi over 4 do work. And then we can make the observations as well as note that cosine 0 is 1, which definitely works, to also get that cosine has a total of 5 working values. And now tangent time. Tangent of pi over 6 is square root 3 over 3. Square root 3 is about 1.7, less than 1.8. 1.8 divided by 3 is 0.6. So tangent pi over 6 is going to be less than 0.6. So that does not work. Tangent pi over 4 is going to be 1. That works. And tangent pi over 3 is going to be square root of 3. That definitely works. But tangent pi over 2, it's a vertical line with an undefined slope. So that does not work. But it turns out that tangent has a period of pi, as in take pi over 6, add pi, and take the tangent of that, and you get the exact same thing. This means that tangent has a total of 4 working values. As for cotangent, cotangent is basically the reciprocal of tangent. Period is still pi, and that basically now means that cotangent of pi over 6 works, but cotangent of pi over 3 doesn't. So that basically means that cotangent has basically 4 values. Now comes secant and cosecant. Turns out that secant is basically the reciprocal of cosine, and cosecant is the reciprocal of the sine. And if you notice from the unit circle, you notice how like the x coordinates and y coordinates always stay within 1, at least for the absolute value. This basically means that the secant of an angle will either be greater than or equal to 1, or less than or equal to -1. This basically means that we only have to care about the values where the cosine of an angle or the sine of the angle is positive. Positive and not 0, because then that will mean the secant and cosecant is undefined. Let's tackle secant first. So from that unit circle where the x coordinate is positive, we get a total of 7 working values. So secant is going to be 7. As for the cosecant, that's going to be when the y coordinate is positive, also 7 values. So that means cosecant is going to be 7. And looks like we've handled all the casework, and let's add them up. 5 plus 5 plus 4 plus 4 plus 7 is 32. And that means that the probability is going to be 32 over 96 equals 1/3. And we are done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.